Good day everyone. This is me, Khaye or Mutia, and welcome back for another video of solving. This video is for the fulfillment for our final examination in Calculus 1, Math 1-1E. For today's video, we will be solving logarithmic, exponential, trigonometric, and minima and maxima problem. Hope you will enjoy this video. Y is equals to ln, fourth root of 3x squared plus 5 times 3x cubed minus 15. So the derivative of ln to the fourth root of 3x squared plus 5 and 7x cubed minus 15, we have to apply the chain rule. So 1 over fourth root of 3x squared plus 5 and 7x cubed minus 15, we will find the derivative of fourth root of 3x squared plus 5 and 7x cubed minus 15. So here we solve it clearly. The derivative of fourth root of 3x squared plus 5 and 7x cubed minus 15 is 105x raised to the power of 4 plus 105x squared minus 9x over 4 times 3 of x, 4 open parenthesis 3x squared plus 5 and 7x cubed minus 15 raised to the power of 3 fourths. So after solving the derivative of this one, we will have the 1 over fourth root of 3x squared plus 5 and 7x cubed minus 15 times 105x raised to the power of 4 plus 105x squared minus 9x over 4 times 3 squared plus 5 and 7x cubed minus 15 raised to the power of 3 fourths. So to simplify the answer, the final answer will be 105x raised to the power of 4 plus 105x squared minus 90x over 4 times fourth root of 3x squared plus 5 and 7x cubed minus 15 times 3x squared plus 5 and 7x cubed minus 15 raised to the power of 3 fourths. So, exponential function. We have here the problem y is equals to 2.7e raised to the power of 3.7x times 4 plus e7 raised to the power of 7x raised to the power of negative 2.74. The derivative of 2.7e raised to the power of 3.7x, open parenthesis, 4 plus e raised to the power of 7x, close parenthesis, raised to the power of negative 2.74. So, take the constant out. So, 2.7 times the derivative of e raised to the power of 3.7x times 4 plus e raised to the power of 7x raised to the power of negative 2.74. So, apply the product rule. F is equals to e raised to the power of 3.7x. Then our g is 4 plus e raised to the power of 7x parenthesis raised to the power of negative 2.74. So, we will have here, for our equation is 2.7 times the derivative of e raised to the power of 3.7x times 4 plus e raised to the power of 7x raised to the power of negative 2.74 plus the derivative e raised to the power of 7x raised to the power of negative 2.74 times e raised to the power of 3.7x. So the derivative of e raised to the power of 3.7x is equals to e raised to the power of 3.7x times 3.7. Then the derivative of 4 plus e raised to the power of 7x raised to the power of negative 2.74 is equals to negative 19.18 e raised to the power of 7x over 4 plus e raised to the power of 7x raised to the power of 3.74. So, after solving this one and after solving the derivative of each, the result will be 2.7 times e raised to the power of 3.7x times 3.7 times 4 plus e raised to the power of 7x minus 2.74 plus open parenthesis negative 19.18 e raised to the power of 7x over 4 plus e raised to the power of 7x raised to the power of 3.74 times e raised to the power of 3.7x. To simplify this equation, the answer will be 2.7 times negative 15.48 e raised to the power of 10.7x plus 14.8 e raised to the power of 3.7x over e raised to the power of 7x plus 4 raised to the power of 3.74. Trigonometric function. Our problem is y is equals to log 8 cosecant x over a, where a is constant in this equation. So, the derivative of log 8 cosecant x over a, we have to apply the log rule, which is log b is equals to ln b over ln a. The derivative of ln cosecant x over a over ln 8. Take the constant out, so we have the 1 over ln 8 times the derivative of ln cosecant x over a. We have to apply the chain rule. So, 1 over cosecant x over a times the derivative of cosecant x over a. The derivative of cosecant x over a is equals to negative cotangent x over a times cosecant x over a over a. Then here we have the 1 over ln 8 times 1 over cosecant x over a times negative cotangent x over a times cosecant x over a over a. So to simplify this equation, we have the answer of negative cotangent x over a over 3 ln 2a. So minima and maxima problem. We have here the given of a rectangle with a length of 8 inches by the width of 15 inches. So let length is equals to 8 minus 2x and the width is equals to 15 minus 2x and the height is equals to x. So to find the value of v, we have to use the equation of length times width times height. So 8 minus 2x times 15 minus 2x times x. So we have here 120 minus 46x plus 4 x raised to the power of 2 times x. So the value of v is equal to 120x minus 46x squared plus 4x cubed. So the derivative of that equation is 120, because 120 times 1 is equals to 120, minus 92x plus 12x squared. So dv over dx is equals to 0. So factor out this 120 minus 92x plus 12x squared. So factoring these two, we will get the 4 times 3x minus 5 and x minus 6. So our x is equals to 6, then x is equals to 5 over 3 or 1.67. So we will substitute the value in here in this equation. So our x is equals to 6. V is equals to 8 minus 2. Substitute the value of x to 6, then 15 minus 2 times 6 times 6. So 8 minus 12 and 15 minus 12 times 6. So negative 4 times 3 times 6. So we will get the value of negative 72. Then if our x is equals to 5 over 3 or 1.67, v is equals to 8 minus 2 times 1.67 times 15 minus 2 times 1.67 times 1.67 is equals to 8 minus 3.34 times 15 minus 3.34 times 1.67. Then 4.63 times 11.63 times 1.67 is equals to 8.92. So x must be equal to 5 over 3 or 1.67, not 6, because it will be equal to 0 or negative. First derivative of 120 minus 92x plus 12x squared is equals to derivative of 120 minus derivative of 92x plus derivative of 12x squared is equals to 0 minus 92 plus 24x is equals to 24x minus 92. The second derivative of this equation is d2 over dx2 is 24x minus 92, so 92 will be equals to 0, so the derivative of 24 is equals to 0. So that's all for this video. Hope you enjoy it and you learned something.